X-ray characteristics. In this video, we'll go into detail about how X-rays are created and the characteristics of X-rays. When the electrons in the X-ray apparatus are accelerated to very high speeds, they impact the target at very high speeds. If we zoomed in very close to the target, we might see something like this. Tungsten is often used as the material of the target, and if we zoom in enough, we can see that these would be the nucleus of tungsten. So the nucleus is positive as it has protons and neutrons in it. Now, being atoms, the nucleus and electrons are largely spaced apart, and the nucleus is a lot bigger than electrons. So when electrons come towards the target, they could pass between different nucleus. So as the electrons approach the target, some electrons might hit the very first layer of the target and head on with the nucleus. In this situation, all the energy of the electron is converted to the energy of a photon. So in that case, that's the most energetic photon that can be created. In other cases, the electrons might have a near miss, where they go close to a nucleus and change direction, losing energy here, however, also emitting a photon. So depending on the electrons, how they approach the nucleus, different levels of energy photons will be created. This is another diagram showing the same thing. So we have some electrons that hit the target and release maximum energy photons. Other electrons pass near the target with lower energy photons. And then some electrons might actually hit the target electrons head on. And anytime this happens, there's a characteristic energy based on what the target material is that's emitted. Deriving an equation to find the maximum energy. So the maximum energy of a photon that's emitted is equivalent to the maximum energy of the electron as it crosses that field. And when it hits that target nucleus head on, all of that energy will be transferred to the photon's energy. So the energy of the electron is given by its energy as it passes through the field, which is the charge on the electron and the voltage, the very high voltage of the X-ray apparatus. Now, as the energy of a photon is given by HF, this can be rearranged, and you can find the maximum frequency of that photon is this equation here. And you can see it depends on the charge on the electron, Planck's constant, but most importantly, the very high voltage of the X-ray apparatus. So this is a diagram of the X-ray spectrum, and it has three characteristics that we need to note. The X-ray spectrum is continuous. The German word for it is Bremsstrahlung, and continuous means there's no gaps here. The photons that are created can be close to zero, all the way up to a maximum value, and anything in between. Because remember, the energy depends on how close it passes to a nucleus, and this could be anything. Another characteristic is these sharp points. This is a characteristic of the target material, and it's related to when the electrons hit the electrons of that target material. Another characteristic is this maximum frequency, which is dependent on the high voltage of the X-ray apparatus. Explain why X-rays are produced with a range of different energies.